In this class, let's talk about the flame tests. Now, this mandatory experiment links in with Bohr theory, and what we're going to do is we will test salts of different metals and show that each metal produces its own unique colour when burned. So what we're actually looking at is the photons of different energy or different colour coming from the metals as your electrons go from a higher energy level to a lower one, and then photons of colour is emitted. Now, right, so the equipment that we need. This experiment is a nice short one, and it is quite common on the exam. There's not a whole lot that the examiner expects you to be able to do here. The first thing that I want you to focus in on is the procedure itself. Now, when the procedure is asked, it comes up for 9 to 12 marks. So you have to be able to describe in detail what you did and have a fair idea why you did it. But then after that, you have to be able, if the examiner gives you the name of a metal, you have to be able to say what color flame would be produced by that metal. Right, so my equipment, we need some damp wooden splints, a Bunsen burner, and some salts. We need 6 different metal salts. Now, the procedure, we're going to soak wooden splints in water overnight. So soak the splints in water overnight. That's your first 3 marks in your procedure. Basically, you just put them into a beaker of water and leave them alone for the night. Now, what that's going to do is your splints will soak up some of the water so that when you hold the splint in the Bunsen burner, the only colour flame that you should see is from the salt itself. It's not going to be from the splint catching fire and interfering with the colour that you see. Number 2, the next step is to tell me that you put the salt on the splint. Now, whether you say it like that, put the salt on the splint, or dip the splint into the salt, either one, it doesn't matter. So dip a damp wooden splint into the salt, 3 marks. Then you hold that salt in the blue flame of a Bunsen burner. Now, it's important that it's the blue flame of the Bunsen burner for 2 reasons. Number 1, it's hotter, and number 2, it's going to be easier to see the colour. A Bunsen burner has 2 flames, 2 coloured flames, a blue one and an orange one, the safety flame. If you were to keep it on the orange flame, that would interfere with the experiment because one of the metal salts that you will be using will produce a yellowy orangey flame. And you won't know, is that due to the salt or is it due to the Bunsen burner itself? Next, note the colour produced by the salt. Great. Repeat using a different salt using a clean splint. Now that's important, using a clean splint each time. So if I started off with lithium chloride, you dip the damp splint in lithium chloride, hold it in the Bunsen burner, note the colour, and then that goes in the bin. You take a fresh damp splint and then you move on to strontium chloride, etc. And then you note the colour. So you should go through at least 6 splints. Your teacher may put a mixture as well for your 7th one. Now, if you look at the diagram on the right-hand side, you could also be asked to draw a diagram of the setup of this experiment, and that is as simple as draw a Bunsen burner with a stick in it and label it as well. Now, on the next page, let's have a look at the 6 different metals and the colours that they produce. So we have lithium, that will produce a crimson flame. Now, it's important that you use the word crimson because you can't say red. It's more of a pinky red, like a magenta. It's a dark pink colour. It's not red. If you were to hold lithium chloride beside strontium chloride and hold them side by side, the colours produced are completely different. So just be careful of your language here. Lithium is crimson. The next one is potassium. That produces a lilac flame. It can be a little bit difficult to see, but it is a nice lilac flame. If some of you did the alkali metals test when you're doing the trends topic, if you cut off a piece of potassium and put it into a basin of water, the potassium itself, because it's reacting so vigorously with water, the hydrogen gas ignites and then you will see a lilac flame due to the potassium. Next, barium. Now this one's a tricky one. I need you to put a star beside this because when you did this one in school, barium, I've yet to come across this one actually giving a nice green flame. It tends to look yellow, but you're going to say green in your exam. Barium is one of the most commonly asked metals in terms of the flame test results. So you need to know barium is green. It's technically yellowy green, but just call it green. Strontium is red. It's a nice dark red color. Copper is blue-green. Now be careful of your language here. You can't just say blue because it's not. Copper is a blue-green color. It's both of them together in the flame. And sodium is yellow. Next time you're walking down the street, if you see these lovely yellow lamps, the older style lamps, they are called sodium lamps. So they produce this yellowy orange. Now, they're all 6 of the ones that you're expected to know for Leaving Cert level, and come up with some sort of a mnemonic that's going to help you remember what colour is associated with each metal. Now, the salts that we were using are lithium chloride, potassium chloride, barium chloride, strontium chloride, copper chloride, and sodium chloride. The chloride you can completely ignore in this. The different metals have different numbers of electrons. They have different electron transitions. So therefore, we're going to see different colours coming from them. Now, an example of the flame tests or using metals like this to produce colour, they're commonly used in fireworks to produce different sparks in fireworks. Now, some of you might have used an alternative method, which I'm going to mention here at the end. The vast majority of you would have used the damp splints, but there is another one where you would use a piece of wire, but you would use the same piece of wire over and over and over again. Now, as you can imagine, you need to be careful of cross-contamination so you don't see multiple colours all together when you put the piece of wire in the flame. So you need to make sure that you're cleaning it properly in between each step. If you're using the damp splints, you're not going to clean them in between each one. They just go straight in the bin and then you take a fresh one. But with this, you're reusing the piece of wire, so it is important to clean it. Now, the examiner will phrase your question in a way where they will let you say which method you used. They're not going to bring up this method here involving the wire because most of you will not have specifically seen this, but some of you might. So the first step with this, clean the wire by dipping it in hydrochloric acid. So if you're given a fresh piece of wire by your teacher, you still don't know what's on it, so you need to clean it first. You put it into HCl, you give it a good swish around in the acid, and then you hold it in the blue flame of the Bunsen burner. So if there's any other residual stuff on the outside of the wire from previous experiments, it's then removed. And you would repeat that up to 3 times. Next, step 2. You take the wire, you dip it in some HCl so it's a little bit wet, and then you dip it into the salt that's being tested. Then you hold it in the blue flame of a Bunsen burner and note the colour produced. Now, when you're finished, you have to take that wire and go back around to step 1, where you dip it in HCl, then hold it in the Bunsen burner to clean it. And you would need to clean it about 3 times before it's properly clean to allow you to then test the next salt. As you can imagine, there's a lot of faff and cleaning involved in this. You spend most of your time cleaning the bit of wire. So it's a lot easier and a lot faster if you were to use the damp splint. Now, some of you might have also used the spray bottles where you spray the dissolved salt in methanol, usually, into the flame, and it creates this fantastic fireball of different colours, depending on which salt you were using. I love that one, but I don't do it very often, just because somebody always tries to nick the spray bottle with the fancy flame stuff in it. Now, that one I love because it helps you to feel like Harry Potter for 5 minutes, but also it's one of the fun experiments that we can do. Don't worry, you've got titrations ahead of you later on. But it is one of the nice experiments that a lot of people associate with chemistry, is setting stuff on fire and seeing what happens. Right, that's it for the flame tests.